The struggle against stubborn belly fat in the later decades of life is not merely a matter of vanity but a profound biological signal that the internal landscape of the human body has shifted. For millions of adults over the age of 50, the frustration is palpable and often heartbreaking, as the dietary restrictions and exercise regimens that once yielded rapid results in their 30s and 40s now seem utterly futile. This phenomenon is not a failure of willpower, but rather a physiological inevitability driven by a complex mechanism known as immunosenescence and the gradual alteration of the gut microbiome. To understand why weight loss, specifically in the abdominal region, becomes a Herculean task for seniors, we must look beyond the simplistic calories in, calories out model and delve into the microscopic ecosystem that governs our metabolism. The human gut is home to trillions of bacteria, a dynamic community that dictates how we store fat, how we regulate insulin, and how we manage systemic inflammation. As we age, the diversity of this microbiome naturally diminishes, creating a state of dysbiosis where opportunistic inflammatory bacteria begin to outnumber the beneficial commensal strains that once kept our metabolism running like a well-oiled machine. This microbial imbalance is directly linked to the accumulation of visceral adipose tissue, the dangerous fat stored deep within the abdominal cavity wrapping around vital organs like the liver and pancreas. Unlike subcutaneous fat, which sits harmlessly under the skin, visceral fat is metabolically active, functioning almost like a rogue organ that pumps inflammatory cytokines into the bloodstream, further disrupting metabolic function and creating a vicious cycle of insulin resistance and weight gain. Therefore, the key to unlocking weight loss for the older demographic does not lie in starvation or excessive cardio, which can be detrimental to aging joints and muscle mass, but in the strategic restoration of the gut microbiome through specific, scientifically validated probiotic strains. When we examine the scientific literature surrounding geriatric obesity and metabolic syndrome, a clear pattern emerges suggesting that the composition of gut bacteria is a primary driver of weight management. Research indicates that the ratio of firmicutes to bacteroidetes, two major phyla of bacteria in the gut, tends to skew unfavorably as we age, promoting increased calorie extraction from food and higher fat storage. This means that an older adult could eat the exact same amount of food as a younger person yet absorb significantly more calories from that meal simply because their gut bacteria are more efficient at harvesting energy. This biological reality necessitates a targeted intervention, one that reintroduces specific bacterial strains capable of reversing this metabolic slowdown. Among the vast library of probiotic strains identified by modern science, 3 specific candidates have emerged as superior allies for the aging body, offering a non-invasive and highly effective strategy to combat central adiposity. These are not generic probiotics found in sugary supermarket yogurts, but specialized strains with clinical backing for their ability to modulate fat metabolism. The first of these powerful biological agents, and perhaps the most extensively studied in the context of visceral fat reduction, is a unique strain known as Lactobacillus gasseri. This particular bacterium acts as a metabolic gatekeeper, fundamentally changing how the intestines process dietary fat. In a landmark multi-center study involving adults with obese tendencies, the administration of Lactobacillus gasseri was shown to significantly reduce body weight, waist circumference, and specifically visceral fat area over a period of 12 weeks without any additional dietary restrictions. The mechanism by which Lactobacillus gasseri operates is nothing short of fascinating and represents a breakthrough in our understanding of bio-weight management. Unlike stimulants that ramp up heart rate to burn calories, Lactobacillus gasseri functions mechanically within the digestive tract by inhibiting the absorption of dietary fat. It effectively binds to fat molecules in the small intestine, preventing them from being broken down and absorbed into the bloodstream. Instead of being stored as stubborn belly fat, these fat molecules are encapsulated and excreted from the body through bowel movements. For an older adult whose metabolism has naturally slowed, this mechanism provides a critical advantage, essentially creating a calorie deficit without the need to drastically reduce food intake, which is crucial for maintaining nutritional status and preventing sarcopenia or muscle loss. Furthermore, the impact of Lactobacillus gasseri extends beyond simple fat excretion. It plays a pivotal role in regulating the expression of genes related to fat metabolism. Scientific analysis suggests that the presence of this probiotic strain can down-regulate the genes responsible for adipogenesis, the formation of new fat cells, while simultaneously upregulating genes involved in fatty acid oxidation. This dual-action approach means that the body is not only absorbing less fat from the diet, but is also being signaled to burn existing fat stores more efficiently. For the senior demographic, this is particularly important because it targets the deep, inflammatory fat that contributes to metabolic syndrome and cardiovascular risk. The reduction of visceral fat achieved through Lactobacillus gasseri supplementation leads to a subsequent decrease in circulating inflammatory markers, thereby addressing the root cause of inflammaging, the chronic, low-grade inflammation that accelerates the aging process and promotes disease. However, the efficacy of Lactobacillus gasseri is contingent upon its survival and colonization within the gastrointestinal tract. The aging gut presents a harsher environment, often characterized by altered pH levels and slower transit times, which can make it difficult for standard probiotics to thrive. Therefore, when discussing the integration of this strain into a senior's health regimen, it is imperative to focus on delivery systems and consistency. The strain must survive the acidic journey through the stomach to reach the intestines where it performs its metabolic magic. Once established, Lactobacillus gasseri begins to remodel the gut environment, producing short-chain fatty acids that nourish the colon lining and improve gut barrier integrity. This is significant because a leaky gut allows endotoxins to enter the bloodstream, triggering systemic inflammation that blocks insulin receptors and promotes fat storage, a condition prevalent in older adults. By sealing the gut lining and reducing this endotoxic load, Lactobacillus gasseri restores insulin sensitivity, allowing the body to process carbohydrates more effectively and preventing them from being converted into visceral fat. This creates a physiological environment that mimics the metabolism of a younger individual. It is not an overnight miracle, but rather a consistent biological renormalization. The clinical data supports a sustained effect. Participants in studies who ceased taking the probiotic eventually saw a return of the fat, indicating that for seniors, Lactobacillus gasseri should be viewed not as a temporary cure but as a permanent dietary staple. Beyond the direct reduction of adipose tissue, the introduction of Lactobacillus gasseri into the senior diet addresses the often overlooked psychological aspect of weight loss, the feeling of satiety. As we age, the signaling between the gut and the brain can become disrupted, leading to delayed feelings of fullness and unintentional overeating. Lactobacillus gasseri influences the secretion of leptin, the satiety hormone, helping to recalibrate the appetite control center in the brain. While the mechanical blockade of fat absorption provided by Lactobacillus gasseri offers a formidable physical defense against weight gain, it addresses only one dimension of a multifaceted physiological puzzle. The second, and perhaps more insidious, barrier to weight loss in the elderly population resides not in the adipose tissue itself, but in the intricate, invisible wiring that connects the gut to the brain. This biological superhighway, known as the gut-brain axis, is the primary command center for hunger, cravings, and stress responses. As we age, this communication line often becomes distorted by chronic low-grade inflammation and hormonal fluctuations, leading to a condition that many seniors describe as an uncontrollable compulsion to eat, particularly sugary or carbohydrate-rich foods, even when they are not physically hungry. This phenomenon is frequently driven by cortisol, the stress hormone, which tends to remain elevated in older adults due to sleep disturbances, chronic pain, or general physiological stress. Elevated cortisol explicitly targets the abdominal region, instructing the body to store fat viscerally as a survival mechanism. Therefore, a truly effective weight loss protocol for the over 50s must include a biological agent capable of modulating this neural signaling, effectively quieting the food noise that sabotages dietary discipline. This brings us to the second powerhouse probiotic strain in our triad, Lactobacillus rhamnosus. Lactobacillus rhamnosus, particularly the specific strain often identified in clinical literature as LGG, acts as the psychological anchor of the weight loss triad. Its primary function is distinct from the fat-blocking action of Lactobacillus gasseri. Instead, it functions as a modulator of the host's appetite and emotional state. Scientific inquiries into this strain have revealed its remarkable ability to influence the production of neurotransmitters such as gamma-aminobutyric acid, GABA, which promotes relaxation and reduces anxiety. By calming the nervous system directly from the gut, this probiotic reduces the cortisol spikes that trigger stress eating. The clinical evidence supporting Lactobacillus rhamnosus is compelling, particularly for women, who often struggle more with hormonal-driven weight gain post-menopause. In a pivotal study published in the British Journal of Nutrition, researchers observed that women taking Lactobacillus rhamnosus lost nearly twice as much weight as those in the placebo group over a 12-week period. However, the most profound finding of this study was not just the initial weight loss, but what happened afterward. During the subsequent 12-week maintenance phase, where participants were no longer actively restricting calories, the group supplemented with Lactobacillus rhamnosus continued to lose body mass, while the placebo group began to regain the weight they had lost. This anti-rebound effect is the holy grail of geriatric weight management. For older adults, the cycle of yo-yo dieting is metabolically devastating. The ability of Lactobacillus rhamnosus to support sustained weight maintenance suggests that it fundamentally alters the body's set point. Furthermore, Lactobacillus rhamnosus has been shown to improve gut barrier function, preventing the leakage of lipopolysaccharides, LPS, into the bloodstream. When LPS enters the circulation, it triggers systemic inflammation that can impair the function of leptin receptors in the brain. By reinforcing the gut wall and reducing this inflammatory cascade, Lactobacillus rhamnosus resensitizes the brain to leptin, restoring the natural sensation of satiety. Moreover, the benefits of Lactobacillus rhamnosus extend into the realm of blood sugar stabilization. However, while Lactobacillus gasseri blocks fat and Lactobacillus rhamnosus controls appetite, there remains a third critical biological hurdle: the natural depletion of the Bifidobacterium genus and the rise of insulin resistance. As we enter our 6th and 7th decades, our microbiome undergoes a specific type of deterioration where Bifidobacteria, the friendly bacteria that dominate the gut of healthy breastfed infants and young adults, precipitously decline. In some seniors, these populations become almost undetectable. This loss is catastrophic for metabolic health because Bifidobacteria are the primary producers of short-chain fatty acids, SCFAs, specifically acetate and butyrate, which are the fuel source for our mitochondria and key regulators of insulin sensitivity. Without a robust population of these bacteria, the body loses its ability to process carbohydrates efficiently, turning even healthy complex carbs into visceral fat. This severe deficiency leads us to the necessity of the third component of our probiotic strategy: Bifidobacterium animalis subsp lactis. Unlike the Lactobacillus strains which primarily inhabit the small intestine, Bifidobacterium animalis subsp lactis colonizes the large intestine, the final frontier of digestion. The inclusion of this specific strain is non-negotiable for seniors because it directly targets the visceral adiposity associated with metabolic syndrome. Clinical trials have demonstrated its unique capacity to reduce trunk fat mass specifically. The mechanism revolves around the suppression of pro-inflammatory cytokines such as TNF-alpha and IL-6. In the aging body, adipose tissue is an active endocrine organ that secretes these inflammatory chemicals, which in turn block insulin receptors. Bifidobacterium animalis subsp lactis effectively breaks this cycle by lowering the intestinal inflammatory load, allowing insulin receptors to function properly again. This shifts the body from a storage mode to a burn mode, which is particularly vital for seniors struggling with insulin resistance. To fully grasp the transformative power of Bifidobacterium animalis subsp lactis, one must understand the currency of the colon, short-chain fatty acids, SCFAs. When this specific probiotic strain encounters the dietary fibers that have survived digestion in the upper tract, it initiates a fermentation process that produces butyrate, acetate, and propionate. Butyrate, in particular, acts as a primary energy source for the cells lining the colon, keeping them tightly packed and impervious to leakage. But its reach extends far beyond the gut. Once in the bloodstream, butyrate travels to the mitochondria and enhances their efficiency. For a senior experiencing fatigue, this translates into a tangible boost in daily energy levels. More importantly for weight loss, butyrate has been shown to stimulate the release of glucagon-like peptide 1, GLP-1, the very same hormone targeted by modern weight loss drugs. By naturally elevating GLP-1 levels through the proliferation of Bifidobacterium animalis subsp lactis, the body is instructed to slow down gastric emptying and curb appetite in a physiological manner. However, the efficacy of Lactobacillus gasseri, Lactobacillus rhamnosus, and Bifidobacterium animalis subsp lactis relies heavily on one crucial factor: survivability. The human stomach is an evolutionary incinerator designed to kill incoming pathogens. If a senior simply swallows a generic capsule, there is a high probability that the bacteria will be destroyed. This reality necessitates a discerning eye when selecting a supplement. One should look for formulations that utilize delayed-release capsules, enteric coatings, or spore-forming technologies to ensure the bacteria arrive at their destination alive. A lower count of survivable, targeted organisms is infinitely more effective than a high count of dead ones. Furthermore, introducing these seeds into the garden of the gut is futile if the soil is barren. This brings us to the concept of symbiotics, the strategic combination of probiotics, the bacteria, and prebiotics, the fertilizer. Prebiotics are specific types of non-digestible fibers that feed beneficial bacteria. Without this fuel, the probiotics you consume will struggle to establish a permanent residence. For the aging gut, which can be sensitive to roughage, selecting the right prebiotic is delicate. The ideal fuel for our triad of fat-burning strains includes gentle, soluble fibers such as acacia fiber, partially hydrolyzed guar gum, PHGG, or specific inulin derivatives. These fibers ferment slowly, providing a steady food source for the bacteria without creating excessive gas. Integrating these fibers into the diet ensures that the Lactobacillus and Bifidobacterium strains have the resources they need to multiply and crowd out the inflammatory, fat-storing bacteria. The timing of administration also plays a subtle but significant role. While debate exists, the consensus for these specific strains leans towards taking them either 30 minutes before a meal or just as a meal begins. Taking them with food buffers the stomach acid slightly, raising the pH to a level that is less lethal to the bacteria, thereby increasing the survival rate. Consistency, however, remains the golden rule. The reshaping of the microbiome is not an acute event but a chronic process. It takes approximately 3 months of daily supplementation to see a significant, lasting shift in the microbial landscape and the subsequent reduction in visceral fat. The first few weeks may be characterized by minor digestive adjustments, a sign that a turf war is taking place in the gut as the new, beneficial bacteria displace the old, pathogenic residents. Patience is required. Seniors should be encouraged to view this not as a quick fix, like a headache tablet, but as a biological investment, similar to watering a plant every day knowing that the bloom will come in due season. The visible results, the loosening of the waistband, the reduction in bloating, the surge in energy, are the trailing indicators of the profound microscopic healing occurring within. Ultimately, the journey to losing belly fat after 50 is not about punishing the body for aging. It is about understanding the unique physiological changes that define this season of life and adapting our strategy accordingly. By leveraging the specific powers of Lactobacillus gasseri, Lactobacillus rhamnosus, and Bifidobacterium animalis subsp lactis, we offer the body a comprehensive toolkit for rejuvenation. This triad addresses the root causes, inflammation, dysbiosis, and hormonal resistance, rather than just the symptoms. It empowers the older adult to take control of their health in a way that is sustainable, scientifically sound, and deeply respectful of their body's needs. As we bid farewell to the stubborn fat that has plagued us, we are not just improving our silhouette. We are reducing the risk of chronic disease, protecting our cognitive function, and reclaiming the vitality necessary to enjoy the golden years with vigor and joy. The gut is the foundation of our health, and by tending to this inner garden with the right bacterial allies, we prove that biology is not destiny, and that it is never too late to reset, rebuild, and thrive.